Hey everyone, have you ever done a chemistry experiment and wondered why reaction didn't produce as much as you expected? Today on Target Tutors, we are diving into why reactions often don't give us as much product as predicted. We will explore the concept of theoretical yield, what percentage yield tells us about a reaction's efficiency, and even some common reasons why we don't always hit 100%. By the end of this video, you will understand not just the math behind the percentage yield, but also how it connects to the real world chemistry like in industrial production or pharmaceutical research. Grab your notebook, sharpen those pencils, and let's get started on mastering percentage yield. What is percentage yield? Percentage yield compares the amount of product you actually obtain in an experiment, actual yield, to the amount you should theoretically get it everything went perfectly, theoretical yield. The formula for this percentage yield is equal to actual yield divided by theoretical yield multiplied by 100. Why is percentage yield important? In real life chemistry, no reaction is 100% efficient due to losses like incomplete reaction, side reactions or experimental errors. In resource management, helps chemists optimize processes, reduce waste and save money in industrial production. And in experimental analysis, allows students and researchers to evaluate the success of their reactions. We are now moving to the calculation, step-by-step breakdown. Step 1. Determine the theoretical yield. Use stoichiometry to calculate the maximum amount of product possible based on the balanced chemical equation. And this depends on the limiting agent, that means the reactant that runs out first. Step 2. Measure the actual yield. This is a product you physically measure after running the experiment, and the units must match the theoretical yield, example in grams or moles. Step 3. Plug into the formula. Use the formula to calculate the percentage yield. Example, suppose you start with 28 grams of nitrogen N2 and excess of hydrogen H2. After the reaction you obtain 34 grams of ammonia NH3. The reaction is N2 plus 3H2 produces 2NH3. Step 1. Find the theoretical yield. The number and molar masses of nitrogen N2 is equal to 2 times N is equal to 2 times 14 is equal to 28 grams per mole. The number and the molar mass of NH3 is 2 times 1N plus 3H is equal to 2 times 1 times 14 plus 3 times 1 is equal to 2 times 17 is equal to 34 grams per mole. Number of moles of nitrogen N2 is equal to 28 divided by 28 is equal to 1 mole of nitrogen. Number of moles of NH3 is equal to 34 divided by 17 is equal to 2 moles of NH3. So 1 mole of nitrogen N2 produces 2 moles of NH3. 1 mole of N2 is equal to 28 grams. 2 moles of NH3 is equal to 17 times 2 is equal to 34 grams. Step 2. Measure the actual yield. Mass of ammonia NH3 obtained is 34 grams. Step 3. Finding percentage yield using the formula. Percentage yield is equal to actual yield divided by theoretical yield multiplied by 100. Is equal to 34 grams divided by 34 grams times 100 is equal to 100%. Example 1. Simple reaction. In a reaction, 5 grams of reactant A produces 3 grams of product B. The theoretical yield of product B is 4 grams. Calculate the percentage yield. The solution for this question, percentage yield is equal to actual yield divided by theoretical yield times 100 is equal to 3 divided by 4 times 100 is equal to 75%. Example 2. Chemical reaction in moles. In a reaction between sodium Na and chlorine Cl2 to form sodium chloride NaCl, 23 grams of sodium reacts with excess chlorine to produce 50 grams of sodium chloride NaCl. The theoretical yield is 58.5 grams. What is the percentage yield? The reaction is 2Na plus Cl2 produces 2NaCl. Solution for this question: 2 moles of sodium Na produce 2 moles of sodium chloride NaCl according to the balanced equation. So 1 mole of sodium produces 1 mole of sodium chloride. 1 molar mass of sodium is 23 grams. 1 molar mass of sodium chloride is 58.5 gram. Theoretically, 23 grams of sodium produces 58.5 grams of sodium chloride. With excess of chlorine, 23 grams of sodium produces only 50 grams of sodium chloride. Percentage yield is equal to actual yield divided by theoretical yield multiplied by 100 is equal to 50 divided by 58.5 times 100 is equal to 85.47%. Example 3. Reaction involving limiting reactant. 10 grams of hydrogen gas H2 reacts with 89 grams of oxygen O2 to form water H2O. Theoretical yield of water is 90 grams, but only 82 grams of water is collected. Find the percentage yield of water. Percentage yield is equal to actual yield divided by theoretical yield multiplied by 100. It's equal to 82 divided by 90 times 100 is equal to 91.11%. These examples illustrate different scenarios in calculating percentage yield. One with direct mass, one with moles and limiting a reagent, and one combining these concepts. Due to the following reasons, the percentage yield will be less than 100% of the theoretical yield. The reasons include: incomplete reaction, that means not all reactant convert to products, or side reactions, competing reactions produce unwanted products, or losses during experimentation, spills, evaporation, or inefficient recovery. That wraps up our journey into the world of percentage yield. We explored what it means, why it is important, and how to calculate it step by step. Got questions? Drop them in the comments below, and don't forget to let me know what topics you would like to see next. If you found this helpful, hit that like button, share it with your fellow learners, and of course, subscribe for more exciting lessons in science and chemistry. Thanks for watching, and until next time, keep learning, keep experimenting, and keep crushing those chemistry goals. See you soon. Bye now.